Hi all. So we were discussing theory of computation homework 1 solutions, and these questions are taken from Peter Linz chapter 1. So let's continue. Let's see this question. So in this question you can notice that let alphabet be a comma b, and this is the language AABB. Then use the set notation to describe the complement of L. So what is the complement of L? We know that every language is a subset of sigma star. Sigma star has all the strings. Okay, this sigma star, it has all the strings, so everything is a string. You can notice in the sigma star everything is a string. So this sigma star is set of all the strings. Now what is a language? Language is set of strings, so I can say that this is a language. We can say that this is a language because language is what? Language is set of strings, set of some strings, I can say. So this is a language. So finally we know that by definition language is set of strings, and this sigma star is this is set of all strings. Language is set of strings, like for example this is set of strings. So this language is set of strings and sigma star is set of all strings. So for any language L, what I can say, for any language L, complement will be what? Complement will be basically all the strings which are in sigma star but not in L. Because remember, for every language this sigma star is working like a universal set, because this sigma star has all the strings. Every string is in the sigma star, and you can notice for every language, whatever language you take, because every language is what? Every language is a set of strings. So for every language you can notice that sigma star is a universal language. Okay, or I can say for every language sigma star is superset. Whatever language you take, for every language sigma star is superset. So I can say that this is how we define the complement of L. Complement of L will be sigma star minus L. I can say complement of L will be all the strings of sigma star which are not in L. Okay, all the strings of sigma star which are not in L. So this is the definition of complement. L complement means all the strings which are not in L. Okay, so this is the definition of complement. Now the first language is given to you. This alphabet is given to you A comma B, and this language is given to you which is AA comma BB. So this language is given to you. Now what the question is asking? The question is asking what is L complement. So remember, L complement will have all the strings which are not in L. So you can notice this string is not in L, this string is not in L, this string is not in L. Next you can notice this string, these are not in L. And after that every string is not in L. For example, every 3 length string is not in L, every 3 length string, every 4 length string, every 5 length string, every 6 length string, that is not in L. So I can say this L complement. What I can say, this L complement I can write like this. This L complement is basically this string is not in L, this is not in L, this is not in L, A, B, B, A, these union. Okay, so this L complement, remember this is your L complement. This L complement I can write like this, that these strings union. Remember, these strings union these strings. Okay, and what are these strings? These are the strings of length at least 3. So I can say these are the strings. These are the strings of length at least 3. These are the strings of length whose length is at least 3. So this is the idea. So L complement is what? You can notice this is your L complement. L complement means these strings, the set of these strings union all the strings which are of length greater than equal to 3. So finally I can say that L complement, that will be these strings union all the strings which have length greater than equal to 3. Okay, this is your L complement. So this is your question number 6 we have seen. Now let's see question number 7. What this is saying, that if L is any language on non-empty alphabet. Okay, so this L is a language on non-empty alphabet, then show that L comma L complement cannot both be finite. Means, okay, L comma L complement, they both cannot be finite, means at least one of them must be infinite. This is what your statement is saying. So this question number 7, what this question number 1 is, question number 7, what this is saying, that let us assume you have alphabet, non-empty alphabet you have. This alphabet can be anything. For example, unary, binary, ternary. Okay, this alphabet can be anything. Basically, non-empty alphabet you have. This alphabet you have. Now, in this alphabet you have at least one symbol. There is at least one symbol. You can have any number of symbols. I can because the definition of alphabet, what is that? Definition of alphabet means this is a non-empty finite set. So let's assume these are the alphabet symbols. So you can notice this is an array. Okay, if this is your alphabet, then I can say that your alphabet is basically an array alphabet. Okay, so anyway, so this is your alphabet. Now Now what the question is asking, the question is saying that prove that L comma L complement both cannot be finite, means at least one of them must be infinite. So the question is saying that this is what we have proved. We have to prove that at least one of at least one of at least one of L comma L complement is infinite. Definitely at least one of L comma L complement is infinite. So this answer is very simple, because you know what is L, what is L complement. L complement means sigma star minus L. Okay, because you know that sigma star is set of all strings, this is the set of all strings, and every language, this sigma star is set of all strings, and every language is set of strings, so every language is subset of sigma star, I can say. Every language that is subset of sigma star. Now you can notice that by okay, so this, for every language I can say, for every language this sigma star is the superset. So I can say for languages this sigma star is working as a universal set. So I can say, what we can say, we can say that L union L complement, what that will be, remember if this is your sigma star, please understand that if this is your sigma star, let us assume this is your sigma star. Okay, and let's assume this is L, and let's assume this is L. Okay, this set of strings, let's assume this is L. Then what is L complement? L complement is those strings which are not in L. Okay, so those strings which are not in L. So this is the L complement. So you can clearly see that L union L complement, that will be universal set. Okay, and universal set is sigma star. So L union L complement is sigma star. Now you know that sigma star is infinite, because this is set of all strings. This is set of all strings. So this sigma star, this is set of all strings. And how many strings you can create? If your alphabet is this, if you have any alphabet, unary, binary, ternary, n-ary, okay, any alphabet you have, then how many, this sigma star, this is set of all strings, how many strings you can create? Infinite number of strings you can create. Okay, so infinite number of strings means number of strings that will be infinite, number of strings that will be infinite. Okay, so this sigma star, this is an infinite set. Now if this is an infinite set, then you can clearly see they both cannot be finite. You can clearly see that they both cannot be finite. Okay, I can say that if L comma L complement both are finite, if both are finite, are okay, both are finite, if L comma L complement, if both are finite, then what will happen? If both are finite, then what will happen? Then this will happen that if both are finite, this is a finite and this is also finite, then definitely this also will be finite, because L is finite, L complement is finite. If I assume that these are both are finite, then this is also finite, this is also finite, but this should be sigma star, L union L complement, this should be infinite set. So there is a contradiction. Okay, so there is a contradiction, so we have a contradiction. So finally, because we have a contradiction, so I can say that our assumption is wrong. It means our assumption is wrong. What is our assumption? That both are finite. This assumption is wrong. So I can say that, okay, I can say that at least one of them is infinite. I can say at least one of L comma L complement is infinite set. At least one of them is infinite set. This is your question number 7. Very simple question. Okay, so we have done question number 6, question number 7 of Peter Linz chapter number 1. Now let's move on. Let's see question number 8. What this question number 8 is saying? Is there any language for which this is possible? Let's check it out. Okay, this is very simple question. Is there any language for which this will happen? Now one thing you observe that if you have any language, whatever language you take, if you have any language, that can be any language, empty language or universal language or any language, any set of strings you take. Okay, if you take any language L, then what will happen? Remember what is L star? What is L star? L star means L power 0, union L power 1, union L power 2, union and so on. This is your L star. And what is L power 0? What is L power 0? That is set containing empty string. So you can notice whatever L you take, it does not matter. Finally, I can say that this empty string definitely belongs to L star. Okay, this we can guarantee that any language you take, whatever language you take, then L star is equal to L power 0, union L power 1, union L power 2 and so on. And you know what is L power 0? That is set containing empty string. So when you take the union, then finally I can say that in this L star, definitely this empty string will be there. We can guarantee that empty string definitely belongs to, okay, let's assume empty string, let's call it lambda. So you can see that this empty string definitely belongs to L star. Okay, definitely belongs to L star, whatever L you take. whatever language you take, whatever language L you take, whatever language L you take, then I can say that this empty string will definitely belong to L star. Okay, by the definition of L star, so this empty string definitely belongs to L star. Now you can clearly see that. So if L is a language, this L is a language. If this L is a language, then L complement is also a language. Now let's look at this side. Okay, let's look at this side. L complement whole star. What you can guarantee, because there is whole star. Okay, this is a language. Any language whole star. Any language whole star. So I can guarantee that in this you have empty string. Definitely I can say empty string belongs to this one. I can say let's call it number 2. Okay, let's call it RHS. Let's call it RHS. Let's call it RHS. And let's call it LHS. Let's call it LHS. Then I can say that empty string definitely belongs to RHS. Definitely, whatever L you take, whatever language L you take, definitely I can say that this empty string belongs to RHS. Now think about it and tell me what will happen on the LHS. You can notice that what is LHS? LHS is basically L star whole complement. L star whole complement. Now you can notice that because this is L star, so I can say here empty string definitely belongs to L star. I can say empty string definitely belongs to L star because for any language L, empty string definitely belongs to L star. Okay, so here I can say that empty string definitely belongs to this language. In this language, empty string is definitely there. If in this language empty string is there, then I can definitely say that in the complement empty string will not be there. So I can say this empty string will not be there in this LHS. Okay, because you can notice what I'm saying. I'm saying in this L star empty string is definitely there because for any language L, empty string definitely belongs to L star. Okay, now I can say if empty string belongs to, if empty string belongs to this language, then empty string does not belong to complement. So I can say that this empty string does not belong to RHS. You can notice empty string definitely belongs to RHS. Empty string belongs to RHS. Empty string does not belong to LHS. So we can say that there is no language, there is no language such that these two can be same. Okay, so I can say there is no language, no, there is no language such that these two can be same, because you can notice on this RHS empty string is definitely there, on this LHS empty string is definitely not there. Okay, we can, so whatever language you take, this will happen. So I can say there is no language such that this will happen. There is no language. Okay, this is your question number 8. Now let's see question number 9, what this question is saying. So this is again very simple question, that prove that L1 L2 whole reverse is equal to L2 reverse L1 reverse. Okay, for all languages L1 L2. Now this is a very simple question, but here what we have to do, we have to use this fact that we have already seen. If you remember in the question number 1 or 2, we have already seen in the previous lectures. Okay, this is your, I can say this is the third part of homework number 1 solution. Okay, so in the homework 1 solution part 1, in the part 1 of homework 1 solution, we have already seen this result. This result we have already seen, that if you have any strings, so if you have any two strings, if you have any two strings, you have any two strings like w comma x, if you have any two strings, then we know that wx whole reverse, that will be equal to x reverse w reverse. Okay, this result we already know, this result we have already seen. Now using this result you can very easily prove that if you have any two languages L1 L2, then L1 L2 whole reverse, that will be equal to L2 reverse L1 reverse. And how to prove it? Very simple. So let us assume that L1, remember L1 comma L2, these are two languages. So let's assume L1 is this type of language. In L1 you have this type of strings like W1, W2, W3 and so on. Let's assume this type of strings you have in L1, and let's assume that in L2 you have this type of strings x1, x2, x3 and so on. So this type of strings you have in L2, let's assume. Okay, and what we have to prove? We have to prove that L2, L1, L2 whole reverse. So tell me, if let's assume L1 has this type of strings, L2 has this type of strings, then what will happen in L1 L2? First let's check what will happen in L1 L2. L1 L2 means string of L1 followed by string of L2. So in this L1 L2 every string will have two parts. In this L1 L2 what will happen? A string of L1 followed by a string of L2. I can say string of L1 followed by string of L2, string of L1 followed by string of L2. Okay, string of I can say, okay, string of L1 followed by string of L2, string of L1 followed by string of L2. Okay, like this. So in this L1 L2, I can say that every string in this L1 L2, every string is like this, that I can say string of L1, string of L1 followed by string of L2. Okay, string of L1 followed by string of L2. Now this is your L1 L2. Now if this is your L1 L2, then what will happen? What will be the strings in L1 L2 whole reverse? Okay, so if this type of strings you have in L1 L2, then which type of strings you will have in L1 L2 reverse? What will happen in the L1 L2 reverse? In the L1 L2 whole reverse. So what you will do? Basically, this is your L1 L2, this is your language L1 L2. Now let's do the reverse of this language. So that will be x1 w1, next x2 w2, and so on. Okay, so basically this type of strings you will have in L1 L2 whole reverse. So in L1 L2 whole reverse, what you will have, remember, in L1 L2, please understand that in L1 L2 every string is like this, every string is like this. Okay, every string is like this, wixj, this type of strings you have. Okay, in L1 L2 this type of strings you have, that string of L followed by string of L, string of L1 followed by string of L2, means string of L1 followed by string of L2. This type of strings you have in L1 L2, string of L1 followed by string of L2, string of L1 followed by string of L2, like this. So in L1 L2, what you, in this L1 L2 whole reverse, what you will have? In this reverse, what you will have? In this reverse you will have this type of strings. In this reverse, basically L1 L2 whole reverse. So what will be the reverse of this? Because this type of strings you have in L1 L2, so what will be reverse of this? The reverse of this will be xj reverse, wi reverse. This type of strings you will have in L1 L2 whole reverse. So I can say that L1 L2 whole reverse. Okay, what type of strings you have? This type of strings you have where, this type of strings you have where I can say xj reverse, wi reverse, means okay, this type of strings you have in this L1 L2 whole reverse, this type of strings. Okay, now let's see what will happen in this language, like in L2 reverse followed by L1 reverse. What will happen? Okay, in this what will happen? Now in this what will happen, see, every string will have two parts. Okay, in this L1 L2 reverse followed by L1 reverse, what will happen? In this will happen that every string will be, it will be like this, string from L2 reverse followed by string from L1 reverse. Okay, string from L2 reverse, string from L2 reverse, string from L2 reverse followed by string from L1 reverse. Now what type of strings you have in L2 reverse? In L2 reverse, okay, L2 reverse will have this type of strings, means x1 reverse, x2 reverse, x3 reverse. So I can say in this L2 reverse, in this L2 reverse you have this type of strings, this type of strings x reverse, this type of strings you have in L2 reverse, x reverse. In L1 reverse, in L1 reverse, the reverse of L1, that will have this type of strings w reverse. You can notice that here also we have x reverse, w reverse, this type of strings. Here also we have x reverse, w reverse, this type of strings. So finally I can say these two are same. Okay, so I can say that L1 L2 whole reverse, that is same as L2 reverse, L1 reverse. Okay, this is your proof. Very simple proof. Okay, very simple proof. Let me tell you another method, another way to prove. Okay, let me to tell you proof number two. Proof number two, let me tell you. See, okay, let's see this L1 L2 reverse. Let's look at this L1 L2 reverse. You know, by the definition of L reverse, what should be L reverse? L reverse must be, okay, reverse of w where w belongs to L. Okay, so this is the definition of L reverse. In L reverse we have the reverse of strings of L. So if some string belongs to L, then its reverse will belong to L reverse. Okay, this is the definition of L reverse. Now what will happen in the L1 L2 whole reverse? So in this you have those strings in this L1 L2 whole reverse, you have the reverse of those strings, the reverse of those strings which belong to L1 L2. Okay, very simple. Basically L1 L2 whole reverse. So in this L1 L2 whole reverse, you have the reverse of those strings which are in L1 L2. So for example, if w belongs to L1 L2, then its reverse will belong to L1 L2 whole reverse. Okay, so this is what you have in L1 L2 whole reverse. Now remember, if w belongs to L1 L2, then what should happen? This we have already seen, that if any string belongs to L1 L2, This we have already seen that if any string L1, L2. So if any string belongs to L1, L2, then what should happen? In this L1, L2, every string will be like this. Okay, string of L1 followed by string of L2. 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 Like this. So in this L1, L2, every string is like this. Every string is like this, that string of L1, string of this. Okay, basically in L1, L2, every string has two parts. In this L1, L2, every string has two parts. Okay, one part is coming from L1 and the another next part is coming from L2. So in this L1, L2, what I can say, in this L1, L2, every string can be broken into two parts. In this L1, L2, in this language L1, L2, every string can be broken into two parts. The first part is coming from L1, the second part is coming from L2. So every string can be broken into two parts. I can say first part is coming from L1, second part is coming from L2. This part is coming from L1, this part is coming from L2. So I can say that like this. So you can notice if W belongs to L1, L2, then I can break this W into two parts. What I can say? I can say that this W is basically nothing but something YZ belongs to L1, L2. Okay, because this W I can, okay, so this W I can break. What I can say, W belongs to L1, L2. What it means? It means that this W can be broken into two parts. This W belongs to L1, L2. It means this W has two parts. First part is coming from L1, the second part is coming from L2. So this W can be broken into two parts. First part is coming from L1, second part is coming from L2. So this W is YZ. This W is YZ. This W is YZ such that Y is coming from L1 and Z is coming from L2. This is your W is equal to YZ. If W is equal to YZ, then I can say here YZ whole reverse, because W is equal to YZ. Now you know that this Y comma Z are strings. This Y is a string of L1, this Z is a string of L2. Now you already know that if you have two strings, if you have two strings, if you have two strings like YZ whole reverse, if you have two strings, then that will be Z reverse, Y reverse. So what we will get? We will get Z reverse, Y reverse. Okay, such that Y is coming from L1 and Z is a string in L2. Okay, so this is your. So now finally, so what we have? We have L1, L2 whole reverse. In this, what we have? We have Z reverse, we have Z reverse, Y reverse, such that this Z is this Z belongs to L2 and this Y belongs to L1. Okay. Now what I can say, what I can write it. Remember, Z reverse followed by Y reverse. This is a concatenation. This is a concatenation. Z reverse concatenated with Y reverse. Here you can notice Z is coming from L2 and Y is coming from L1. So I can write it like this. I can write it Z reverse, where Z is coming from L2. Okay, concatenated with Y reverse, where Y is coming from L1. Okay, very simple. Okay, what I'm saying, see, Z reverse, Y reverse. This is Z reverse concatenated with Y reverse. Here Z is coming from L2, Y is coming from L1. So I can say, I can write it like this. This concatenation, this ultimately both are the same thing, because if you notice both are the same thing. Here Z reverse, Z is coming from L2. Here Y reverse, Y is coming from L1, and this is the concatenation. If you do the concatenation, again you will get this. So both are same. Now what is this one? What is this one? Z reverse, where Z belongs to L2. What is this one? Okay, what is this one? Okay, think about it. Z reverse, where Z belongs to L2, means if some string belongs to L2, then its reverse we have. If some string belongs to L2, then its reverse we have. So basically this is your L2 reverse. Okay, similarly, Y reverse, where Y belongs to L1. So what is this? This is basically Y1 reverse. Okay, and this is your proof. L1 L2 whole reverse, that is equal to, okay, L1 L2 whole reverse, that is equal to L2 reverse dot L1 reverse. Okay, so very simple question. This question number 9, very simple question. We have done the proof. Okay, so this proof is very easy. Like proof number 2, this proof number 2, step by step I am going. See, in this proof number 2, step by step I am going. What I am doing, I am only using the definition of reverse, nothing else. The definition of reverse we are using. Okay, and very simple, step by step you can do this. So this is the proof of question number 9. Okay, so we have done question number 9. Now let's solve this question. This is question number 10, and the question is saying that prove that L star whole star is equal to L star for all languages. Okay, so this is a very simple question, but before we solve this question, let me solve a simple version of this question. Let's solve the simple version. So the simple version is like this. First, what we will do, we will prove that L star that is equal to L star for every language, whatever language you take, whatever L you take, for all languages L, for all languages L, for all languages L. So any language you take, then L star that will be equal to L star. Okay, how to prove it? So first of all, you can very easily say that this is a set. You know that this is a set, and you also know this is a set. So how to prove that two set are equal? This is the idea, how to prove that two set are equal. So if I want to prove that two set are equal, like let's assume I have set A, I have set B, and if I want to prove, if I want to show, if I want to prove that A is equal to B, if I want to prove that two sets are equal, then what should I do? Then I should do two things. What should I do? I should prove that A is subset of B, means every element of A is every element of A is also element of B. I also have to prove that B is subset of A. So these two things I need to prove. Okay, that every element of A is element of B and every element of B is element of A. This is what we have to prove if we want to prove that two set are equal. Now you can notice this is also a set, this is also a set, because every language is a set, every language is a set, every language is a set. And so every language is a set. L star, that is also set of strings. This L star, this is also set of strings, so this is also set. So these are set. Now we want to prove that two set are equal. Now clearly you can notice that this set is definitely subset of L star. This L star, every string of L star definitely belongs to L star, because what you can do, you can clearly see what you can do. Remember, every string of L star, that definitely belongs to L star, because if some string belongs to L star, then what you can do, let's assume some string belongs to L star, this W, let's assume some string belongs to L star. So if this string belongs to L star, then what will happen? This string belongs to L star, then what will happen? Then you can notice this string also belongs to this, because W belongs to L star. I am saying that this, okay, some string belongs to L star, then what will happen? Then it will happen that W belongs to this, because W belongs to L star, so W belongs to this. So I can say W is here. Okay, W belongs to L star. And you also know that in L star we have empty string, definitely. Okay, you know that for whatever L you take, for all L, for all L, this empty string definitely belongs to L star. For any language L, the empty string definitely belongs to L star. So I can say that empty string, that definitely belongs to L star. So you can see that what I'm saying that basically what I'm proving that this is a subset of this, means RHS is subset of LHS. This is what I'm proving. So if I want to prove that RHS is subset of LHS, then what should I do? I should prove that every string of RHS is also a string in LHS. Every string of RHS is also present in LHS. So let me assume that you have some string in RHS. Let us assume W is a string in L star. Then because I am assuming that W is a string in L star, so it means W belongs to L star. And you also know that W belongs to L star, that is fine. You also know that for every L, this empty string belongs to L star. Now what will happen? Now what will happen? Definitely you can notice that W is here and empty string is here. So when you do the concatenation, it will be like this. Okay, it will be like this. W is here, okay, concatenated with empty string is here. Okay, some other things are there. Okay, so W is in this L star. In this L star you have W, in this L star you have empty string. So finally when you do the concatenation, what will happen? When you do the concatenation, then this W will definitely be there. So I can say that if any string belongs to L star, then that string definitely belongs to L star L star. So this is the proof. So what we have done? So we have proven that RHS is subset of LHS. This RHS, this is definitely subset of LHS, means this L star definitely, this L star, this is a subset of L star, means every string of L star is also a string of L star L star. This is what we have done. Now what we have to prove? We have to prove that LHS is subset of RHS. Now we have to prove this. Now we have to prove that this LHS, means this L star, this is a subset of L star. This is what we have to prove. Means every string here is also a string here. And this is very easy to prove, because you can notice that, let's assume that the L is some language. Okay, this L is some language. In this L, what you have? In this L, you have this type of strings. Let's assume these are the strings in L, W1, W2, W3, and so on. So these are the strings in L. Let us assume these are the strings in L. If these are the strings, because L is a language, so this is a set of strings. So these are the strings in L. Now, if you have some string in L star L star, then what you have? So which type of string you have in L star L star? Just think about it. You can notice that if this is your language L, then which type of strings will be in the L star? So in L star, in L star, which type of strings will be there? In L star, this type of strings will be there. That, okay, basically I can say, we have already seen what type of strings are in L star. Okay, so in the previous lecture, in the homework 1 part 1, homework 1 discussion part 2, okay, homework 1 discussion part 2, we have already seen the analysis of L star. We have already understood L star, and we know that if you have any language L and these are the strings, then which type of strings will be in the L star? This type of strings will be in the L star, like W1, W2, okay, W1, W3, W4, okay, like this type of strings will be in the L star, okay, and so on. So I can say that this type of strings will be in the L star. Means in L star, you have this type of strings where, where basically, okay, I can divide this into some parts such that every part is a string of L. Okay, so very simple. This is what I'm saying. See, this is very simple to understand. What I'm saying, that if L is like this, let's assume W, X, Y, Z, and so on. If this is your L, then what is L star? L star means L power 0 union L power 1 union L power 2 union L power 3, and so on. So in L star, this type of strings you will have. Because of L power 0, you will have empty string, and because of L power 1, you will have all these strings. Okay, so you will have all these strings. Now, because of L power 2, you have this type of strings which have two parts, like WX, WW, okay, XY, and so on. Okay. Similarly, because of L power 3, you have this type of strings like WWW, okay, which have three parts. Every part is a string of L, like XYW, okay, like XXW, and so on. Okay, so and so on. Basically, in L star, what you have? In L star, you have this type of strings. In L star, you have this type of strings you have in L star. In L star, you have this type of strings. Okay, this type of strings you have in L star. Correct? This type of strings we have in L star. So finally, what I'm saying, that if I assume that this is L, if I assume L is W1, W2, this is your L, if I assume, then which type of strings are in L star? This type of strings will be in the L star. Now, okay, this type of strings are in the L star. So in this L star, you have this type of strings. Of course, this, okay, in this L star also you have, okay, so in this L star, for example, remember, this L star has nothing to do with this L star. Of course, they are same. This L star, they are same. But when you are doing the concatenation, then every string of this L star will concatenate with every string of this L star. Okay, it's like this. Please understand that. For example, okay, let me take let me take this L equal to X comma Y comma Z. Let me take this. Then what will happen in L star? See, in L star, this type of strings will be there. Like in L star, you have this string, this string, this string, okay, this string X Y Z, this string XX, X Y Y Z, or this type of strings you have in L star. So when you do L star, okay, now if you do L star, then what will happen? Every string of L star will concatenate with every string of L star. Like every string of L star will concatenate with every string of L star. Will concatenate with every string of L star. Remember? So I can say every string of L star will concatenate with every string of L star. Okay? Every string of L star will concatenate with every string of L star. Okay, so like this will happen. So you can notice. Now, what I'm saying, that this type of strings you have in L star. So now, when you do L star, then what will happen? So in this L star, which type of strings will be there? In this L star, in this L star, we have this type of strings where every string of L star is concatenated with every string of L star. So basically, in this L star, what will happen? Every string of L star will concatenate with every string of L star. I can say that, for example, this is a string of L star. Okay, you can notice this is a string of L star. Now this string of L star will concatenate with every string of L star. Okay, so this is a string of L star. this will concatenate with another string of L star, this will concatenate with every other string of L star, like this. Okay, like this. So you can notice that every string of L star will concatenate with every string of L star. Of course both are same. Remember, here also you can notice this this L star is same, but what will happen, every string of L star will concatenate with every string of L star. Like this string of L star will concatenate with itself, also it will concatenate with this and so on. Okay, so like this will happen. So finally what I can say, that in this L star you have this type of strings. What we can say, that if your L is like this, W1, W2, W3, W4, if I assume this is your language L, then in this L star, this type of strings you will have. In this L star, which type of string will be there? This type of strings will be there basically. This type of strings will be there, like W1, W1, W2, W3, W1, W4, W5. Okay. Okay, so string of L star concatenated with string of L star and so on. Okay, now so in this L star, this type of strings you have, this type of strings you have. Now tell me this type of strings you have in L star. Now tell me, this string, does it belong to L star? Does it belong to L star? Of course it belongs to L star, because in L star, remember this string is in L star. This string belongs to L star. Now you can notice that this string also belongs to L star, because in L star you have this type of strings, because you can notice this is from L, 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 so this is also from L. So finally I can say that this string that you have, this string also belongs to L star. I can say this complete string, if you look, this complete string also belongs to L star. This complete string also belongs to L star. So what we have done? We have proven. What we have proven? We have proven that if any string, we have proven that if any string, okay, take any string, if any string belongs to L star, then that string also belongs to L star. Okay, so this is what we have proven. Every string of L star, that is also a string of L star. Okay, so finally what we have done, we have proven that, we have already proven that this L star is subset of L star, means every string of L star is also a string of L star. We have also proven that every string of L star is also a string of L star. From these two things, what I can say, from these two things I can say that L star is same as L star. This is what we have proven. Okay, very easy proof, very easy proof. Okay, now what we have to prove, remember our original problem was this is our original problem, that L star whole star is equal to L star. This is what we have to prove. Now this is very easy to prove. Let us assume L star is A. Okay, for a moment, if you assume L star is A, let's assume L star is A, let's assume L star, that is something A. Then what will happen here? Then this is A star. Okay, then I can say, let's assume L star is A. For a moment I am assuming that L star is A. Then what will happen? L star whole star. L star whole star means A whole star, because I am assuming L star is A. So what will happen here? So this I can write as A star. And what is A star? That is A power 0 union A power 1 union A power 1 union A power 2 union A power 3 and so on. Now what you do? Now you put A equal to L star. Okay, you put A equal to L star. If you put A equal to L star, this will be set containing empty string. This will be set containing empty string. Okay, but if you put L equal to A star, then it will be L star union L star union L star L star L star union and so on. Now we have already seen that L star is equal to L star L star. We have already seen that this is also L star. We have already seen this is L star. We have already seen if this is L star, see, if this is L star, because L star is L star. Okay, so you can notice if this is L star, if this is L star, then you can see that this is also L star. L star, this is also L star. So finally what you got ultimately, you got that L star whole star, that actually will be L star union L star union L star and so on. So what we got, because okay, very simple result. What I am saying that this L star whole star, let us assume this L star is A, let's assume this L star is A, then I can open it, then this L star whole star, I can write it A star, and I can open it like this. Then what it will become? If I replace this A with L star, then what I will get? I will get L star union L star L star union L star L star L star, and so on. Now you can notice that we have already seen L star is equal to L star L star. So this L star L star, this is same as L star. Similarly, okay, now you can notice what I'm saying, that any number of L star you take, it does not matter. L star L star L star L star, what that will be equal to? What that will be equal to? You can notice this L star L star, this is equal to L star, and you can notice this L star L star, this is also equal to L star, and we know that this L star L star, this is also equal to L star. So any number of L star you take, that does not matter, that does not matter. So what I can say, I can say that L star whole star, that is actually equal to, because that is equal to, that is equal to L star. Okay, because any number of L star you take, it does not matter. Any number of L star, like L star power 0 union L star power 1 union L star power 2. L star power 2 means L star L star. L star power 3, that means L star L star L star. L star power 4, L star power 4 union L star power 5. So any L star power you take, what will happen? Everything will become L star. Everything will become L star. This will become L star. Okay, this will become L star. So everything will become L star. Finally, when you do L star union L star union L star union L star, so finally you will get L star. That's your proof. So this proof is actually very simple. Anyway, if you understood, did you understand the proof? Let me know. Okay, so you can comment if you have any doubt, you can comment. Okay, please let me know if you have any doubt. Okay, you can comment your doubt, but this proof is actually very simple if you work it out. Okay, basically take a language L, and then you work it out. So what we have done in this proof, this is what we have done, that for any language, remember, for every language L, whatever language you take, for every language L, this is what we have done. For every language L, we have proven that L star is equal to L star. This is what we have proven. This is the first result that we have proven. L star is equal to L star. This is what we have proven. Now from this you can notice that L star power n, L star any power, okay, power n, that will be L star, means L star power 4, L star power, like this is L star power 2. So L star power n, that will be L star. And from this I can say that L star, any power you make, any power you make, that will be L star. So I can say L star, L star whole star, that will be equal to L star. Okay, so if you understood the proof, then let me know in the comments. You can let me know. Okay, so please let me know in the comments. Okay, if you understood the proof, if you understood these results, like this result and this result, so three results, if you understood all three results, then comment, okay, that you understood. Okay, so make a comment that you understood, and if you have any doubt, you can ask in the comments. Okay, so this is a very simple question, and we have done this. So this is the original question we have to prove. You can notice this is Peter Lynch question. We have to prove that L star whole star is equal to L star for all languages, and this is what we have done. So we started with this. Remember, L star is equal to L star. We started with this. So first we have proven this. First we have proven that L star will be equal to L star. This is what we have proven. Then we have done that L star any power, L star power n. This n can be 2, 3, 4, 5, any power you take, then that will be L star. And from this I can say that L star whole star will be equal to L star. Okay, so this is the idea. Now, so this is your question number 10 in Peter Lynch. In the next video, we will solve this question number 11. We will solve in the next video. You can try this, but I will solve this in the next video. Okay.